Hi there, this is Ms. Martinez, and we are looking at Chapter 9, Section 1, Simplifying Rational Expressions. As a student, I'm looking for you to be able to simplify rational expressions. And that is it. That's the only objective for this lesson. So let's get started. Alright, in the background here, you are hearing a beautiful piece by Niccolò Paganini. It's called Variations on One String. The note C is played on a cello by plucking just the thickest string. By pressing the midpoint of the string to the fingerboard and plucking again, that's going to produce a C note that is one octave higher. Other notes are produced by pressing along the fingerboard there at different fractional lengths of the string. And that's what you're hearing here. He is placing his fingers along actually a violin and playing at different fractions on the same string. And yet it's creating so many different notes. It's really quite fascinating. We're going to see how that length of the string determines the pitch or how high your note is. So talking about fractional pieces, a rational expression is an algebraic expression that can be written as a quotient.
Teachers and students, please excuse this brief interruption.
And that's a brief interruption by Coach Ruby. I am filming this at school.
Clothing from Fan Club when we did our fundraiser a couple weeks ago. Please be sure that you swing by Ms. Ruby's office to pick up your items. They are in. Ms. Ruby does have to go to a meeting at 3:45, so anytime after school, now to after school, or now to 3:45, you can pick up items. If not, you'll need to pick them up tomorrow. Thank you.
Sorry about that. Okay, so it's an expression that can be written as a quotient of two polynomials. So the polynomial p over q. But the thing is, q cannot be equal to 0 because then you'd be dividing by 0, and that is totally not okay. All right, moving on. So examples of rational expressions. You could have L over 2, the length divided by 2. That is a rational expression. C divided by B minus 2. Or you could have x squared minus 2x minus 3 over x squared minus 1. Each of those is an example of a rational expression. But looking at example B, division by 0 is undefined. We know that to be true. So if your B value was 2, you'd be dividing by 2. That means when B cannot equal 2 in the second rational expression, we cannot allow that B value to be 2. That is called an excluded value. It's a value of a variable that would cause an expression to be undefined. In example B, it is undefined at the B value of 2. That is an excluded value. Alright, so here's our first example. Together we're going to state the excluded values of this rational expression. Excluded values, those are values that would make your denominator equal to 0. So we're going to figure out what can the denominator not equal. It cannot equal 0. So let's solve now the expression that you see there. You would add 1 to each side, so x squared cannot equal 1. And now we're just asking ourselves, okay, what number squared would give me 1? To solve that, you would take the square root of each side. And here's a really important factor, a really important note that you need to make. The square root of x squared is actually the absolute value of x, which means what number, when you take the absolute value, is 1? Well, there are two options. It would be positive 1 or negative 1. So the excluded values here are both positive and negative 1. Those are our excluded values. Okay, reducing. We need to remember what that concept means. When you were working with fractions, reducing answers to lowest terms was done by canceling any common factors. So say you had 3/9. Really, that's 3 over 3 times 3. 9 is 3 times 3. So you're able to cancel out a 3 in the numerator and denominator. You're dividing out a 3 in both the top and bottom, and that leaves you with 1/3. It is similar for rational expressions. You reduce rational expressions to lowest term by canceling any common factors. And then you need to just make certain that you include the excluded values like we saw before. So here, if we were asked to reduce this expression, you would factor the numerator and the denominator, which you see I have done here, and they both have an x minus 1 in common. So you would cancel that out, and the result would be x minus 3 over x minus 1, but the values are excluded values. We look back at the original expression, and the values that would make that undefined are either a positive or negative 1. All right, I have 2 more examples, and here's the first of those last 2. So we're going to simplify this rational expression and state any excluded values. That means we're going to need to factor the numerator and the denominator, and when it's factored, determine the excluded values. On top, you could factor out a GCF of 5x, because they both are divisible by 5, both those terms, and you could factor an x out of each term in the numerator. That means that what would be left inside parentheses is an x plus 8. Similarly, in the denominator, both 5 and 40, you could factor out a 5 from, and they both have a y, so you can factor that out. And what is left is x plus 8. Now we need to determine the excluded values. Well, if y was 0 and you multiplied there, then that denominator would become 0, and that would make it undefined. And if your x value was negative 8, then inside parentheses you'd have a 0, and when you multiplied it would make your denominator 0, so negative 8 is an excluded value. Now to give our final answer, in simplified form, we'll cancel the common factors and again state our excluded values. So the canceling, you can cancel the 5s, both GCFs in the top and bottom, and you can cancel the binomial factors because they are same. And so all that is left is x over y and the excluded values of that y cannot be 0 and x cannot be negative 8. All right, last one, and we're going to leave our answer in factored form. We have to factor the numerator and denominator. Now, why don't you try to do that right now? Try to factor both the top and the bottom. All right, let's check and see if you are correct. If you're not finished, pause the video and then press play when you're ready. So on top, the number that they have in common is 63, and you could factor out an a squared because that is the most that of the a's that they have in common. That would leave in parentheses a minus 2. In the denominator, you could factor out a 21. That's the largest number they have in common. And the most a's that they have in common is just 1, which will mean in parentheses a plus 2. This means that a cannot be 0, because if you plugged it into the first a there in the denominator, 21 times 0 is 0. And that, when multiplied, would make your denominator all equal 0. Also, a could not be negative 2, because then in the parentheses, you'll have 0, and 21 times, eventually when you multiply anything times 0, it makes it 0. So that is an excluded value. Excuse me. Now, we're going to cancel common factors. In the parentheses, those are different, so you cannot cancel them. But the numbers we can cancel, and we'll have 3 over 1, because 21 goes into 63 3 times. And we can cancel 1a from the top and bottom. So your final answer will be 3a times a minus 2 over a plus 2, where a cannot be 0 or negative 2. And that's it. Thank you.